In this problem, we want to evaluate the limit, but we get 0 in the denominator if we try to plug in t, 0 for t. So we need to simplify this function. So one way I can simplify it when I have a radical in there is I want to get rid of that radical so I can start eliminating stuff and get that t out of the denominator. So what I'm going to do, I'm going to pull this function aside over here and just call it f of x. And the function is t squared plus 9 all over t squared. Oops, I forgot my minus 3. Careful when you write that square root that you don't go too far so you can tell what is under the square root and what's not. So to get rid of a square root square root, then I can multiply both. It's kind of like rationalizing the denominator, except this time we're actually rationalizing the numerator. So to get rid of the square root, we rationalize by multiplying both sides, both the top and the bottom, the numerator and denominator, by the conjugate. So in this case, the conjugate would be, I should specify that. So if I have the conjugate is where I have a binomial and I just change the sign. But with radicals, it actually helps us rationalize it because the square roots go away. So for another example of a conjugate would be like square root of 2 plus 1. The conjugate of that would be square root of 2 minus 1. So for my f of x, my t squared plus 9 is my radical, so I got to keep that together. And then I change that minus to a plus. And then I think I had t squared in the bottom there. Whoops, whatever I do on the bottom, I want to do on the, and whatever I do on the top, I want to do on the bottom. So I'm actually going to write this part in red. Whatever I do on the top, I got to do on the bottom because that way I don't change the value because there's no equal sign. I'm not doing something to both sides of an equation. So in order to not change the value, I multiply by the same thing on the top and the bottom so that I'm really just multiplying by 1 and I'm not changing the value of the fraction. So as long as I do the same thing to the top and the bottom of the fraction, I haven't changed the value. But the reason I do this is because now when I go to multiply these two conjugates together, you can think of a conjugate as like a difference of two squares. So when I multiply a plus b and a minus b, that's really a squared minus b squared. So the square roots go away. So I have t squared. So this is my a. So that gives me t squared plus 9, and the square root is gone, minus my b, which is the 3 squared. And in the denominator, I have t squared times t squared plus 9, plus 3. Now my square root is out of the numerator, which is good, and the denominator too much because that's going to end up canceling. So let's just keep simplifying the numerator. The numerator, sorry. So that's t squared plus 9 minus 9. So 3 squared is 9, and I can remove the parentheses. And I'm just going to keep the denominator like this because I'm going to end up canceling that outside t squared. because my positive 9, negative 9, those will cancel. And I get t squared all over t squared times square root of t squared plus 9 plus 3. Now my t squares will cancel, and this just becomes 1. So that's 1 over square root of t squared plus 9 plus 3. Now when I plug in a 0, I don't have 0 in the denominator anymore. So now I'm going to take this function. I do want to note that if it's f of x, then I still have that 1 is still, the 0 is not in the domain. So t not equal to 0 because of the original domain. But I can find an equivalent function everywhere g of x is same as f of x except for at t equal to 0. And g of x will be this new function except for at t equal to 0. But again, we don't care about the t equals 0 because that's where we're taking the limit. So we're interested in what the value is as we approach 0, not at 0. So now I have my g of x. So I have limit as t goes to 0 of 1 over square root of t squared plus 9 plus 3. Now I can plug in 0 and I get oh, actually, I don't need to write limit anymore because now I'm going to evaluate the limit. So I'm going to plug in 0, and I get 1 over square root of 0 plus 9 plus 3, which gives me 1 over 0 plus 9 is 9, square root of 9 is 3, plus 3, which gives me 1 over 6. So this limit is 1 over 6.